This podcast will cover direct variation. Direct variation problems cover formulas such as d equals rt, or distance equals rate times time, and v equals md, or volume equals mass times density. In these problems, there is a value called the constant of variation. In the distance problem, the constant of variation is r, or the rate, and in volume problems, the constant of variation is the d, or density of the substance that you're using. In all direct variation problems, as one value increases, so does the other. For example, the longer you drive, the farther you drive. If the mass of an object is better or is larger, its volume is going to be greater. The general form for direct variation problems is y equals kx to the n. In the past, you just said y equals kx. The fact that we add the exponent n allows us to do things like say y varies directly as the square of x, or y varies directly as the square root of x. Now let's take an example of how you do a problem with these. Suppose we know that y varies directly as x and y equals 45 when x equals 2.5. The first thing we would need to do would be to write a direct variation equation. As soon as you see the words y varies, you should automatically start with y equals k. You're always going to have a constant of variation. Then the operation is going to depend on the type of variation. In direct variation, it is always a multiplication problem. So we are going to multiply by whatever follows, which is x. So for this particular problem, our basic formula is going to be y equals kx. Now we're going to take the values we know, substitute them in, and find a value for k. So I know that y is 45, so I have 45 equals. K I don't know, but I know it equals 45 when x is 2.5. Doing the simple division there, I get k equals 18. This means the general formula for this problem is y equals 18x. I can now take the formula y equals 18x and find out what happens at other values of x. For example, part B, use the equation to find the value of y when x equals 4. Simply substitute in 18 for k and 4 for x, and you get y equals 72. In our next example, we're again looking at direct variation. It says an object such as a car, mind you, is accelerating twice the distance d it travels, varies directly with the square of the time t elapsed. A car accelerating for 4 minutes travels 1,440 feet. Let's take a look at what it says about the variation. It doesn't say distance varies directly, it says twice the distance. So we're going to start with 2d equals k because it varies, and then directly means we're going to multiply with whatever comes next, and what came next is the square of time. So 2d equals kt squared. Now if I solve this for d, I get d equals kt squared over 2, and it's asking me to graph it. And I can't graph it because I have too many variables. So I need to use our specific example to find a value for k. So I'm going to substitute in my known distance and my known time so I can get a value for k and then graph my equation. So 1,440 equals k times 4 squared over 2, or 1440 equals 16k over 2. 1440 equals 8k, and k equals 180. This means my general formula for this particular problem is d equals 90t squared. How did I get 90? Well, it was 180t squared over 2. And when I divided the 2 into the 180, I got 90. Now I need to graph that, but before I make my graph, I need to make some good decisions on how I'm going to count my increments on y. I know that when distance is, or excuse me, when time is 0, my distance is going to be 0. When time is 1, 1 squared is 1, so it's going to be 90. When time is 2, though, it's going to jump all the way up to 360. At time 3, it's going to be 810. So I need to get some good increments on here. I'm going to count by 180s. So my first line up is 180, 360, 540, 720, 900, 1080, and so on. On my time axis, I'm going to count by ones. I'm just going to count by minutes. Now, I'm just going to put my numbers in. 0, 0. 1 minute was 90, so it's about halfway up. 2 minutes was 360. 3 minutes was 810, so it's going to be somewhere above halfway in there. And my graph looks just like half a parabola, like I expected it to because of the t-squared. The next part of my problem says use that equation to find the distance traveled by the car in 8 minutes. So I'm simply going to substitute 8 in for t. So I have d equals 90 times 8 squared, or d equals 90 times 64, or distance traveled was 5,760 feet. The next technique is called the proportional method. You can use this, and it kind of bypasses k in the middle. When you have this, we actually have 2 sets of ordered pairs. We have one set where we know everything, and I'm going to call that one x1, y1. You know both values. The other information we have is x2, y2, and on this one we'll know one of the 2 values. Our job is going to be to find the missing value. Now, the formula is set up right there, but I'd like to show you where it actually comes from. If we take the first problem with our known values, we could set that up as y sub 1 equals k x sub 1. Or if we solve that for k, we get y1 over x1 equals k. On our other set of values, we could also start with y2 equals k times x2, or y2 over x2 equals k. Notice on both circumstances, because the values are all related, the constant has to be the same. Since they both equal k, it means they equal each other. So our general formula would be y1 over x sub 1 equals y sub 2 over x sub 2. In the next example, we'll demonstrate how this can be done. In this example, we have the fact that y varies directly. So y varies was y equals directly, y equals k. Directly meant we were going to multiply by whatever followed, and what followed was the cube of x. So in this case, y equals kx cubed, or y over x cubed equals k. If I'm going to bypass k, I have to set up my fraction with my knowns, where I know both values, and then my fraction where I'm missing one. The 2 values I know are negative 67.5 for y, and k was 3, so that's 3 cubed. And that's going to equal negative 540 over our other x value, which is missing. So we'll just call that x cubed. So when we do our cross products, first we need to simplify some stuff. This is negative 67.5 over 27 equals negative 540 over x cubed. We're going to do our cross products, and that's going to give us negative 67.5 x cubed equals negative, and 27 times a negative 540. That would be a negative 14,580, dividing both sides by negative 67.5 gives us 216. So x cubed equals 216. In order to get this answer, we need to take the cube root of both sides. The cube root of x cubed is x, and the cube root of 216 is 6. This concludes the podcast on direct variation.